Hi everyone. So today we'll be continuing with probability questions, but today's random experiment with which we'll be dealing is quite interesting, as the random experiment is drawing cards from a deck of 52 well shuffled playing cards. So the playing cards, I don't know how many of you are familiar with playing cards. Hope very few will be familiar. That's why there is a need to make you familiar with the pattern of the cards. So let me first show you the deck of um, I show you the deck of 52 playing cards. You see the cards are like this. If you see, there are you see, these are the playing cards. Okay, so there are four types of playing cards. So total is 50 days. Now I'll explain you. As you see, the total 52 cards are there here, and there are four types of cards. So 4 and 13 each, because 4 into 13 is 52, and out of this four type, two types are black and two types are of red color. So basically 26 cards here are black and 26 cards are red. Okay, and um, now the two black cards are known as spade and clubs. The symbol for spade is this and symbol for clubs is this. And two red types are known as hearts and diamonds. Hearts is like the shape of heart and diamond is like the shape of diamond. So you have to remember the name of the type of the cards. Spade and clubs are black and hearts and diamonds are red in color. So you can see this, you see, if you can, I don't know whether you can see, this is your clubs. This is your clubs, this symbol is diamond. Then next one is heart, and this is the another black spade. Okay, and then let me now explain you how the cards are distributed. So you see, each of the type, there are four suites. Two suites are black and two suites are diamonds. So in each suite you see that is a A. I have shown you this is your, as you see, this is your A, and this A is known as ace. So for each type there is a one A will be written here. One A I have shown you. This is the A of the hearts. This is A of the hearts or ace of the hearts, and this is ace of diamond, and then lastly the ace of the clubs. So these four cards, that means there will be four aces, two black ace, two red ace. So let me write down, these are ace, four aces. Then there will be 9 numbered cards. You see, oh sorry, this one will not be there because there's I made a mistake. Sorry, this one will not be there because ace is 1. Actually the value of ace is 1. So yes, so the next number is, the second is 2, then 3, 4, 5, 6, 7, 8, 9. So there are 9 numbered cards, as you see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are numbered cards. Then there are 3 face cards. So I show you why they are face card. As you can see, as you see in heart, as you see, these cards are known as face cards, as face is drawn on the cards. This J is known as jack, and then next higher degree is queen. It is written Q over there, and this is king, K. So let me write down these things to be clear. So for jack I'll be writing J, for queen it is Q, and for king it is K. These will be written on the cards. Similarly, okay, similarly for black also, you see, 3 face cards, Jack, J, Q, Queen, and then K, King. So 3 face cards for these clubs. Then for hearts I have shown you. Then for spade also Jack, Queen, King, and similarly for diamonds also there will be 1 Jack, 1 Queen, and 1 King. So total 13 cards. 1 is 9 numbered cards. 9 numbered. So 1 is 9 numbered cards and 3 face cards. So 1 plus 9 plus 3, 13. In this way the cards are distributed in 4 suites. So all these cards are identical in all the suites. Only the colors are different and the symbols are different. So different names are given. So in this way these 52 cards are distributed in this pattern. So you have to remember this pattern. So in total how many aces are there? 1, 2, 3, 4 aces are there. And 2 black ace, 2 red ace. Then how many face cards will be there? 3 face cards in each suite. So 3 into 4, 12. So total it will be 3 into 4. Total face card will be 12. 3 4s are 12. And total ace will be also again 4. Total number of aces is 4. And similarly total numbered cards will be 9 each. So 4 9 are 36. 36 numbered cards are there. 12 face cards and 4 aces. So this thing should be known to you. Then only you will be able to solve the probability questions of this type when the random experiment is like this. So okay, I think this is clear to you. Or I can show you again that you see these are numbered cards. As you can see 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, where is the 10? Yeah, 10. Then face cards J, Queen, and King. So for all the 3 or 4 types, you will be getting this kind of cards. You can show it for them. Let me check. Like this. Here also, like this. So I think this is clear to you how 52 cards are like this. Now when I say well shuffled, so now what is the random experiment? Now you see. Random experiment is a deck of, this is the deck of well shuffled means I'm shuffling this. So I don't know which card is which card is placed where, that I don't know. They are not arranged serially. So when I shuffle a deck of playing card, what does it mean? That is when I draw a card from the deck of 52 cards, so the probability of getting any of the 52 cards are equally likely. So that is the meaning of well shuffled playing card, means these random outcomes of these random experiments are equally likely. So when you have to find the probability in the questions, we can use the theoretical definition or classical definition of probability. Okay. So now let us solve the question. I have taken a question. One card is drawn from a pack of 52 cards like this. Find the probability that the card drawn is an ace, a red, either red or king, red and king, neither red nor king. So 5 events we have described. We have to find the probability of these 5 events. Okay. Now let us first write the definition. Probability. The theoretical definition of probability or the Laplace definition is probability of an event is number of favorable outcomes. Number of outcomes favorable to E. Let me write in this way. Number of outcomes favorable to the event upon number of all possible outcomes. All possible outcomes of the experiment, under the assumption that all the outcomes are equally likely, which is defined by this well shuffle. Okay. So now let us start solving the question one by one. So in the first case, what is the event? Event is ace. It has to be an ace. That means, so what will be the number of, so this is ace, no? So therefore the probability by this definition, number of favorable outcomes. So how many aces are there? 1, 2, 3, 4. 4 aces are there. So 4 is the number of favorable outcomes. And total number of outcomes, any of the 52 cards will be there. So it is 1 upon 13. This is the answer. Now for the second part, what is the event? The event is that the card drawn is red. The card has to be red. So the probability so what is the number of favorable outcomes? The card has to be red. So you see, there are 13 red cards in these hearts and 13 red cards in diamonds. So 13 plus 13, 26. So 26 is favorable outcomes and total is always 52. So it is half. This is the answer. Now actually this is nothing but these are the all possible outcomes, always 52, and this is also known as sample space, as I've told you. So the third event, what is the third event? Third event is either red or king. Either red or king. So therefore the probability, now one thing you see that is very important, this the language is important. When I say or, either red or king, when I say or king, that means the card can be red, the card has to be red, or the card can be king. That is, I have to consider my favorable cards will be all the red cards and all the kings. So how many red cards are there? Again here 13 plus 13, 26, and 2 kings are already included, so I have to consider 2 black kings. So it will be your favorable or number of favorable outcome is your 2 into 13 plus 2 black king. Okay, here 2 black kings are included here. So 2 red kings are included here, and 2 black kings I have to consider. Because of or, I have to consider both the cases by 52. So it is 26 plus 2, 28 by 52. Yes, so if you cancel by 4, 4 7 is 28 and 4 13 is 7 by 30. Then the fourth, what is the event? Red and king. Red and king. Now you see here it is and. In or I consider both, either this or this. Okay, so I have to consider in this way. But when it is and, that means it has to be both red as well as king. It cannot be like this. I cannot take these red cards because it has to be king. So only red kings can be taken. So this red king, king of hearts, and this king of diamond, only these two are our favorable outcomes. So 2 red kings are there. So therefore the probability 2 by 52. So it is 1 by 26. So I think the difference between or and is clear. When it is or, my favorable outcomes are all red and all kings. And when it is and, my favorable outcomes are this red, the king has to be red. The red card has to be king or the king has to be red. That is, these 2 conditions has to be satisfied simultaneously. So that's why this is the thing. Lastly, fifth part, what is the event? There is neither red nor black king. Red nor black king. So the probability, number of favorable outcomes, that means it cannot be red, it cannot be black king also. It cannot be red means I have to omit these two red columns. So I have to consider this spade column and this clubs column. But not black king. So I have to omit these two king also. So among these 26, I have to omit these two kings. So it will be 24. So there are total, neither red means they have to black. So there are total 26 black cards. And since it cannot be black king, so I have to subtract these two black kings. So 26 minus 2, that is 24 by 52. So what will be the answer? If I cancel by 4, 4 6 are 24, 6 by 13. So these are the answers. So in this way, we find out the probability. So finding the probability of this kind of questions, it is very important to know the nature of the sample space, and then only you will be able to write the correct number for the favorable outcomes. So I think you will be able to solve any kind of card problems, this kind of question, if you now if, as you know the sample space very correctly. Okay, so I think this solving this question is enough. Or one question I may give you, where sometimes when I pick up a card, then the card is not replaced. Here all the cards, when I pick up a card, the card is replaced. So sometimes then the question becomes a bit complicated. So I can show you one question like this. Okay. So the next question I've taken is that 5 cards, 10 J and 10 Jack, Queen, King and Ace of diamonds are well shuffled with their face downwards. Okay. One card is then picked up at random. Then you have to find the probability. What is the probability that the card is the Queen? And then what is the second part? If the Queen is drawn and put aside, then what is the probability that the second card picked up is an Ace and then a Queen? So this is the question. So what is that? So what is our sample space, or what is the total number of possible outcomes that we have to write down first? In that random experiment, the total number of possible outcomes of the experiment is, these are the things, that is I have taken, these are the diamond, that is I have taken this 10, I have taken then this Jack, then this Queen, then this King, and then lastly this Ace. So these 5 cards are picked up. So it is 5. And these are the cards. Let me write it down. That is this 10 I have taken, then Jack, then Queen, then King, and then lastly Ace. Okay, this is our sample space. Our total number possible outcome is 5. Now for the first part, what is the event? The event is that the card drawn or card picked up is Queen. So the cards were upside down, so I don't know which card will be picking up, and this is also well shuffled, so this is equally likely outcome. So we can use the classical definition of probability. So what is the event? The card is Queen. So among this there is only one Queen. This is Queen, no? Queen. So therefore the probability is number of favorable outcomes upon total number of possible outcomes. So favorable outcome is only one Queen is there, so it is 1, and total number of outcome possible is 5. So this is the answer. 1 by 5 is the probability of this event, first part. Now the second part, if the Queen is drawn and put aside. Now there's us telling that that is without replacement. That means when I picked up the card, I will not put it back, I put it aside. Okay, so suppose in the Queen is drawn and then it is kept aside, then what is the probability that the second card picked up is an Ace? So first time, suppose in the first, when I picked up the first card was Queen and I kept aside, then I have to find out the probability, that is when I pick up the second card, that should be an Ace. That is the question. So in the second part, since the Queen is put aside, so the total number of possible outcome will be different now. What will be this? Out of this queen has been kept aside. So what is left? 10 is left, jack is left, king is left, and ace is left. All are diamonds. So this is your 4. Now in the first part, part A, what is the event? Is an ace. E is an ace. So therefore the probability of that event will be number of favorable outcome. There is only one ace, so it is 1, and total number of possible outcome is 4, so 1 by 4. Then in the part B, what is the event? The event is that it has to be queen. So event is queen. Now for the required probability, number of favorable outcomes, as this there is no queen, it is kept aside. There is no queen, 0 queen, so it is 0, and total number of possible outcome is 4, so answer is 0. So in this way we find out the probability. So it is always very important to observe what is the total number of possible outcomes and what is the number of favorable outcomes. Okay, so yeah, when in this kind of experiment, when there will be drawing a card or pick up a card, so it is very important to notice that whether this card is replaced after when you are drawing the second card, whether there is replacement of the first card in the deck. If there is replacement, that means you're keeping back after drawing the card, you're picking back in the deck, then the total number of possible outcome will remain same. But if there is replacement, the total number of possible outcome go on decreasing. So that should be taken into account, or be careful. So this is and one more question I can make like that. Suppose this is the random experiment, and if I describe my event like that, what is the probability that you have drawn a card? So what is the probability that the card that you have drawn is a face card? Then what will the probability? Total number of favorable outcomes will be 12, because there are 12 face cards. So it will be 12 upon 52, or 3 by, if we cancel is 3 by 13. See, or the question may be like that. The event is described that when you pick up a card from a deck of 52 cards, well shuffle 52 cards, so what is the probability that the card you have drawn is red face card? Then it will be there are 3 plus 3, 6. So 6 by 52. And same for 6 black face card, it will be also again 6 will be number of favorable outcomes, 6 by 52. So in this way we can find out probability of any event if we can remember this properly, correctly. Okay, so I think that's all for today. I have understood this kind of question. I think you will be now in a position to solve any card question, this kind of any card question, that is when the random experiment this, it will not be a problem for you to solve any question of this category. Okay, so that's all for today. Bye.